Hi guys, welcome to my channel ArgoCap. So today I'll be solving one more problem from the Algo expert site, and the problem name is minimum character for words. And this is a problem from the Sting playlist. So let's understand the problem first. So this is a very important question, and this problem can be come in any interview. So, but I'm not able to find this question any over the internet, not in LeetCode or any other coding platform site. So I thinking just make a video so that you can know what is the problem and how this problem can be solved. Okay. So now let's understand what is the problem statement. Write a function that takes a array of words and returns the smallest array of character needed to form all the words. The character does not need to be in any particular order. Let's say suppose, so basically you will be given a string of words. Okay, let's say your you so this is a string of all words, and you need to return the smallest array of character that is needed to form all of these words. Okay, so to form the word your, what are the character we need? So we need one y, one o, one u, and one r, right? Next, next word is u, right? So to form this u, what we need? We need one u y, so that is already present. One o, that is also in present. One u, so this u also present. Okay. Then the next or. So to form the word or, we basically need one O, one R, and that is already present in our list of character. Okay. Next, we have a Y and O, and Y and O. These are also available. So this is the minimum character needed to form this all of the words. Okay. So this is the answer. Okay. Now let's take another example. Okay. So words is like something this, then that, did, then there is another exclamation mark. Okay, then last word is a. Okay, so this is the all words that we need to form, and we need to return the smallest array of character needed to form all of these words. Okay, so now to form this, what we need one t, right? Then one age as well, and one I, and then one s. Okay, then we need to form that. Okay, so to form that, what we need basically two t, right? One h and one a. Okay, but as of now we have only one t available, right? So basically we need two t to form that, so that's why we need to add another t into in our list of character. Okay, then one h, but h is already present, and one a, but this a is not present, so we need to add that a in our character, right? Next, we have a did. To form did, we basically need two d, one I. Okay, but you can see there is no d available in this our character list. So for that, to form the word did, basically we need two did, so we need to add two d in our character list. Okay, and I, this I is already present because we have previously one I available, so this I can be used to form this word did. Okay, next, what we have a did, so to form did we have a 2d and 2e, right? So but we have already 2d available, right? So do that we can use, but we don't have any e, right? So that's why we need 2e as well, so we need to add 2e in our character array. Okay, next what we have, we have a them and then exclamation mark. Okay, so to form this word we require one t, but we have already two t, right? So we can use that. Then what, age is also available, e is also available, m, but m is not available in our character list, so we need to add m. Then the exclamation marks, this exclamation mark also not available, so we need to add that as well, right? So this is the character word we need. Next we have a word a, but a is already present in our word character, because this a can be used to form this word a. So this is the answer. So this is the minimum character required to need all the words. Okay. So I hope you are able to understand the problem now. So moving to the approach how we are going to solve this problem. Okay, so if you see, like, so at the first what we observe that we have a t h I s. Next, if any word comes that's required 2t, but previously we have 1t that is present, right? But as the new words require 2t, then we need to add one more t in our character list, right? And let's say we if there is, like, to form a new word we need some character that is not also present in our character list, so in that case we need to add that our array as well, right? So if any new character come, that also need to be added. Now let's say if any word comes, and let's say, and those are the not new words, and the whatever the count required for this new word, that is also the count of that character in our answer list. So if that is the case, let's say, like, we have already t, 2t, h and I and s. If any word comes that's have a 1t, let's say 1i, 1s, in that case the like, we have already has those character in our character list, right? So we can simply use that to form this. So that's why, like, if any character that is already present, then in that case we don't need to add it. But if any character, like say, if any word comes which requires 3t, right, but we have only 2t, in that case we need to add another more t. But if a character come which requires 2t, because and in that case we have, as we have already 2t available, then we don't need to add another more t or any other t, right? Because this 2t can be used to form the new words which has a 2t as well. Okay, so this is the approach. So what we can do, so basically we will create a hash map. Okay, so this hash map basically character and then the integer. Okay, so this has map where we store the, like, how many what is the character we need, and how many character we need to form the whole words. Okay, so this is the basically our answer map. And this answer map, after this, like, once this whole answer map will create, then I will just transform this answer map to list of character. Okay, so this is an, and then what we'll do, we'll just simply iterate all the words. Okay, and then what I will do, for every words w, what I'll do, I will first create a frequency of every character. I will try to find out the frequency of every character. Okay, so how can we find the frequency of every character? So for that, what I need to do, I need to take another hash map. Okay, this is also character, and I just write it in short form. Okay, then this is kind of frequency map. Okay, our current frequency map. and then what I'll do, I for every character in frequency, for every character in W, okay, w dot to char array. So what I'll do, I will increase the frequency map count, okay. So what I'll do, frequency dot put our current character, and I will increase, like if it is present, I'll increase the count of that character, 3, 0, then increase by 1, okay. So this frequency map now store the frequency of every character in a for the words W, right? Now once I get the frequency map, then I will check that uh, let's say in our answer map we have a word T uh, with frequency 1, okay, but in our frequency map we have a character T with frequency 2. So that case our answer map will update by 2, right? Because whatever the maximum value for this frequency, if in those two hash map, that will updated in our answer map, okay. So what I will do, I will just iterate this hash map, okay, for every key in this frequency dot get key, okay, for every key, okay. So I will try to put what is the maximum value of that key in this hash map, okay. So what I'm trying to do, basically if a frequency map has a character 2 and character T with two frequency, and but in our answer map have a character T with frequency 1, then this character will updated by 2, because so what I'll do, will just I will just put, so what I will put our answer dot put with our key and the maximum value of those two, like what is the maximum value of that character in both hash map, this map or this map, and then whatever the maximum value that I will put in our answer map, okay. So I am putting answer dot put the key value, and then answer, then the maximum value of dot maximum value of answer dot get frequency dot get key, okay. So in that case maybe there is no like so suppose let's say if in this answer map, okay. So now I'm trying to example that in the answer map as of now, let's say we have a character C with 1, and now let's say in frequency map we have a character D with 2, right? So in that case we need to if I do answer dot get D, that is not available in our answer, right? So either here what we need to do, here we need to do answer dot get or default key comma 0, basically, okay. So if the value present, that will returning that value, otherwise it will return the default value 0, right? So then I will update that value in our answer map, okay. So now our answer has map basically, this answer map basically store the like character and the frequency of that character that are required to form all the words. Okay, then what I'll do, I will just for every character I will iterate that answer map again for key let answer dot key set. Okay, what I'll do, I will what is the value of like it's a character C has a two times, right? So I need to add 2C in our list. Okay, so if I have a list of character list, so what I need to do for if, two times I need to add C, right? So for equal to 0, let's say I less than the answer dot get key. So that is basically the count of that character. Okay, then I plus plus. So then I just need to add list dot add the character is nothing but the key, right? So after that I just need to return the list. Okay, so this is the way we can solve this problem. So what is the time and page complexity for this problem? So like if I have a words, let's say words of length n, and every words has a in, then the time complexity for this problem, basically we are iterating all the words and also iterating all the character of that word. So and then what we did, we just basically putting those value into our hash map, right? So the time complexity for this problem is order of n squares, and uh, if n is the words length and the every character as a in length character, it could be the possible character, like every word should be 26 character or maybe something like that. So in that case the complexity is order into 26 into n. Okay, and you can say the the complexity is order of n only, because the every word length is can be 26. Okay, or whatever the value is given, right? If it is the word length also n, then the time complexity order into n into n, that is basically n square. And the page complexity also same, it could be the as we are storing the all the frequency of character in a hash map. So but we know that we can only store the 26 character, right? So in that case the complexity could be order of 26, because we have only that the hazmat size could be as maximum as 26 or 256, because we have a 256 character only, right? So it could be order of 256, and that could we can take it as a constant or something like that. So the page complexity could be order of constant only. Okay, or order of 26 or 256, the whatever the character length is given. Okay, so I hope you are able to understand the solution. I will also provide my solution in the description section, so please check it out. Thank you.